Good morning. Today we are going to continue factoring for polynomials, and we're going to talk about a formula essentially for factoring sum and difference of cubic polynomials. So quadratic formula here, just a refresher from last unit. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and we should use it when we can't factor. Okay. Fill these in. 1 to the third power is 1, 2 to the third is 8, 3 to the third is 27, so forth and so on. What we're going to do today is we're going to rewrite things using cubes or cube roots. So the cubed root of 125 is 5, and the cubed root of x to the third is x. So if I rewrite that like this, it's the same thing. It's equivalent. Okay, so we're going to use that concept when we do the problems today. Okay, so when we factored using difference of squares, we looked at special patterns where we could take the square roots of both and had a minus sign in the middle of our binomial. For sum and difference of cubes, it works if we can take the cubed root of both parts, and it doesn't matter if we have a positive or negative in the middle or a plus or minus sign. We use SOAP to help us remember the signs, so we just need to know the pattern then. SOAP stands for same sign, opposite sign, and then these two go together. That last sign is always positive. Okay, so when we do this, I try to find my A and my B, and then write this out. The pattern for these two is always the same. So once I figure out A and B, I have A, B, and then a squared, ab, and b squared for both of those. So the pattern is the same. That's where SOAP comes in, and we do same, opposite, always positive. So my original sign here is positive, so I just do same, so positive, opposite, negative, and then always positive. If the original sign is a minus sign, I'm going to do the same, so minus this time, and then change it to a positive, and then the last one's always a positive. Go ahead and pause this video and write these down. Makes a little bit more sense once we go ahead and do a couple problems. Okay. So if we go ahead and do these, what we're going to do is take the cubed root of each part. So we're going to do the cubed root of 343 and the cubed root of 8. Okay, to do these, we're going to start by finding the cubed root of each part. So the cubed root of 343 is 7. And the cubed root of x to the third is just x. So this is our a term. And then the second part is the cubed root of 8, which is 2. So no matter what my sign is, when I plug these in, I'm going to do the same thing. I'm going to bring my a down and bring my b down. And I'm going to square my a, so 7 squared is 49, and then x squared. And I'm going to square my b to get 4, and then I'm going to multiply the 2 together to get 14. Okay, I apologize for the baby's cries. So what I was saying is bring your a down and bring your b down for the first group, and then square your a and square your b for the second group, and then in the middle we're just going to multiply the 2 together. So 7 times 2 gives us 14x. This is where SOAP comes into play. So we are going to do, my original sign is plus, so we're going to do the same, the opposite, and then always positive. Okay. Sometimes it helps if you do GCF first. Excuse me. So notice for number 2, I can actually divide both of those by 8, and it's going to make my life a lot easier. So if I take 8 out of here and divide by 8, I'm left with x to the third power equal minus 64. So the cubed root of x to the third is just x, and the cubed root of 64 is 4. So when I plug those in my first group, I bring down my a and my b. In my second group, I square my a and my b, and then I multiply them together for the middle. Okay, then I just need to decide what sign I'm going to use. So if you look at the original problem has a minus there. So when we do same, opposite, always positive, we're going to keep the same sign, change it, and then the last one is always positive. We just have to put the 8 up front. Okay. Next one, Okay, same thing. Take the cubed root of 1000, which is 10. X to the third is x. Take the cubed root of 27 to get 3. And then the pattern is always the same. So once you have those, bring your a down, bring your b down, square your a, and square your b. Okay, and people miss their exponents there, so make sure you have an x squared there. And then multiply a times b. So 10 times 3 is 30x. Okay, then you just need to decide your sign. So my original sign here is minus, so I'm going to keep it same. Opposite, always positive. Okay. Last one, we're going to go ahead and take a GCF out, so I'm going to divide by 2. So I get 125x to the third plus 216. So then I need to take the cubed root of both parts. So if I take the cubed root of 125x to the third, I get 5x. So that's my a. And if I take the cubed root of 216, I get 6. So that's my b. I'm going to go and plug those in. So same pattern. Bring a and b down for the first group. And then square a, so 25x squared, watch your exponent. Square my 6 to get 36, and then multiply them together. So 5 times 6 is 30x. Shh, buddy. Okay, so my original sign is a plus sign. So I'm going to keep that the same, change it to the opposite, and then make it positive. Okay, so that's the factoring pattern. I'll let you go ahead and try and factor those first, and then I'm going to show you the factoring, and we're going to actually solve from here because we do want to solve at the end. Okay, so hopefully you paused this and tried to factor on your own. We're going to start by taking the cubed root of both parts. So we get 2x to the third. Nope, sorry, just 2x. And we get 3 there. Struggling. Okay, so my first part is 2x. My second part is 3. So I'm going to go ahead and plug that in to my pattern. So remember, we're bringing the 2x and the 3 down for the first group. We're going to square the 2x to get 4x squared, and we're going to square the 3 to get 9. And then we're going to multiply them together, so 2 times 3 is 6, so I have a 6x there. And I need to decide my signs. So looking at my original, I have a plus sign, so I'm going to do the same, the opposite, always positive. And then this one actually says solve. So the last thing I need to do is solve each of these. Here's what I'll tell you. The first one I can solve just fine. Subtract 3, divide by 2, we get negative 3/2. Whenever you use these patterns, you have to use the quadratic formula to solve the second part. It's not possible to factor. So we need to do our b squared minus 4ac. Okay, so I get 36 minus 4 times 4, 9. So I get negative 108 there. And if I break that down like we did with our quadratic formula last unit, the square root of negative 108 is, breaks down, 36 goes into it, so we have 36 times 3. Okay, so when I break this down and use the quadratic formula, I have the opposite of b, so positive 6, plus or minus, and then I'm going to break this down. So the square root of 36 is 6, and I have an I there. 3 stays on the inside. Over 2 times a, which is 4. We're going to simplify that. And then reduce. So for my final answer here, I can divide each of those terms, or each of those parts, by 2. So I'm going to do 6 divided by 2, which is 3, and 3. And then 8 divided by 2, which is 4. And these are my answers here. Okay. Let's do one more. The cubed root of x to the third and the cubed root of 125. So my a is x and my b is 5. So I have x and 5 in my first group. And then for my second group, I'm going to square those. So x squared and 25, and then multiply them together, so 5x. My original sign is a minus sign, so I'm going to do same, opposite, always positive. And I'm going to set each part equal to 0 and solve. So for the first part, I can solve easily. X minus 5 equals 0, so if I add 5 to both sides, I get 5 for that one. For the second one, I can never factor, so I always need to use the quadratic formula, so I'm going to do b squared minus 4ac, which gives me negative 75. And then if I break that down, the square root of negative 75 breaks down to negative 25 times 3. So when I plug it in, I have the opposite of b, plus or minus. Square root of 25 is 5. It's negative 7i. So I have 5i squared root of 3 all over 2 times 1, which is really just 2. So we're going to go ahead and bring these down. My three answers are 5, negative 5 plus or minus 5i square root of 3 over 2. Okay, so whenever you use sum and difference of cubes, you have to use the quadratic formula to solve that second group. It's not possible to do it any other way. Go ahead. If you have any questions, make sure you ask. Good luck. Make sure you do your homework, and have a great weekend.